the internet protocols in your network layer. So internet protocol is a network layer protocol. It is sandwiched between your transport layer and your data link layer. So in your network layer, the important protocols are internet protocols ICMP and IGMP. And there are currently two versions which is used now, that is IP version 4 and IP version 6. So the IP internet protocol is like the waste of a hourglass of the internet protocol architecture. Okay, there are many protocols when you consider in all the other layers, whereas in your network layer the main protocol is your IP protocol. So IP is the highest layer protocol which is implemented at both your routers and host. So when you talk about the delivery service of your internet protocol, it is minimal. So that's why it is unreliable. So to make it reliable, we use certain protocols such as ICMP. And it is a connectionless protocol. So each packet is handled independently. And there is no attempt made on the IP as such to recover the lost packets. Okay. So an IP service is also called as your datagram service. So the consequences when we talk about your IP protocols, it's the higher level protocols have to deal with the losses, and the packets will also get delivered out of sequence. Next, when you talk about the different delivery modes, your IPv4 supports unicast, broadcast and your multicast messages. Okay, and any cast is not supported by your IPv4. Now, so this is your IP datagram format, which consists of your version, which talks about the version. Here it is IPv4. Next, your header length. Next comes your flag called as DS and ECN. Next is total length, then identification, and you have do not fragment and more fragment flags, fragment offset, time to live, protocol, a header checksum, and source and destination addresses. Then you have options, and then comes your payload. So version, as I said before, it is set to 4 here, and header length will be always in the multiples of 4 bytes. Next you have a DS or ECN field. It is called as differentiated service field. So here before it was called as type of service field, okay, which clearly says that what kind of a service is being provided. Okay, and before it was called as DSCP, now it is called as ECN, that is explicit congestion notification. Okay, which is your new feedback mechanism which is used by your TCP. Next you have 3 flags. First flag is always set to 0. Next you have do not fragment flag and more fragments flag. Then you have your fragment offset. So time to live is nothing but your datagram will always have a time to live. So if it crosses that time, your datagram will be dropped. Next is your protocol, okay, where you will specify what protocol you are going to use. So it specifies the higher layer protocols. Okay, and here for error correction we use your checksum, which is of 2 bytes. Next is your options, okay, which is kept for your security restrictions. So options is for your security restrictions. So you have something called as record route, so which will record the route in which your packets is moving. Okay, and you have a timestamp. In timestamp, each router that processes the packet adds its IP address and time to the header. So when it's at the time, you will have they will have the route as well as your time details. And in routing there are 2 types. One is loose routing and another one is strict routing. In loose routing, it specifies the list of routers that must be traversed. Okay, it doesn't conditionally say that we have to follow that route. Whereas in strict routing, It specifies a list of only the routers that can be traversed. Next you have padding.